Okay, so we're going to look at reflecting shapes over axes today, so the x-axis and the y-axis. And this right here is going to serve as our pre-image for both of these. Now, if we look at it, we have the blue house. The blue house has been reflected right here. This is a reflection over the x-axis from our pre-image. And one thing that's really crucial to note and an easy way to figure out where the line of reflection is you look between here. So from there to there, that corner of the house, that's 2 units. It's the same number of units to the corresponding corner on the image as well. So I mean that works with any point you choose. So like the top of the house right here, same right here. If you look at this corner of the chimney, same distance right there and right there. They're both 8 units, so like that's 8 units, that's 8 units. And this is a reflection right over here over the x-axis. From here, boom. Now if we look over here from the pre-image to the orange house, this is actually a reflection over the y-axis. And the same rules still apply. So like right here, this is 4 units away, and this corresponding distance is 4 units away as well. Another good fact to remember is that the orientation changes on this as well. So if we start like from the chimney, go through the top and then around the house, this is going clockwise. But if we reflect over the x-axis from the chimney to the top and then around, that's counterclockwise. And likewise here, that's also counterclockwise to go in the same direction. So you start with clockwise, and once you reflect it, this goes counterclockwise, and then this goes counterclockwise. So what you guys are going to do today is you're going to do an activity on Desmos, and then in case you missed it somehow and you're not looking at the PowerPoint, these are the codes. So figure out what period you're in, use that code, and then try it out. And this does not work on a phone, but it will work on a laptop or a tablet. Now hopefully what you've realized here is there's a pattern that every time you reflect a shape over the x-axis, what happens is you change the y-coordinate. You change the sign of the y-coordinate. So if you start with a general xy situation and you reflect over the x-axis, the x, that first coordinate stays the same, and then you change the sign or you negate whatever's there. So for example, if you started with 2, -3, this would go to 2, which stays the same, and then you change the sign and this goes to +3. Easy, simple. All right, let's check out the y-axis. Now the y-axis has the same general idea of a rule, except instead of changing the y, we're going to change the x. So basically you're just going to change the opposite. Like y-axis, we change the x. X-axis, we change the y. So with this, instead of xy, it's going to be -x, comma, y. Y stays the same. And let's do that same point, 2, -3. 2, -3 is going to go to -2, we change the sign, and then keep that -3 the same, -2, -3.